What's going on YouTube? Today we're going to talk about KAPE or Kroll Artifact Parser and Extractor, the long name for this program. This will be part of a room created by TryHackMe. It's a recent room. I'm gonna show you now the room. So this is it. It's about KAPE. I'm gonna lay down the principles and concepts behind this tool, and then we're gonna jump to a practical scenario where we solve a challenge, a hands-on challenge using this tool. And of course, before I solve the challenge, I will go over the tool and provide you with explanations on how it works. So let's first go over the concepts. So definition: Kroll is, or KAPE is, a forensic tool to extract Windows forensics artifacts. So you can extract artifacts from either live system. A live system is a system that you inspect in real time without any sort of imaging process, or you can inspect or extract artifacts from a mounted image. Say you have imaged the system using a tool such as a FTK imager, in-case, or even you have captured a memory image, memory dump using volatility. You can extract artifacts from the image using KAPE. Now, if you wonder what do we mean by saying artifacts, in general, artifacts are forensic objects that you would collect to reach a forensic fact. But in computer, that's in general. But in computer forensic, we define artifacts as anything of forensic value that would aid in an ongoing investigation. So artifacts in digital forensic can be registry keys or hives. Also web activity and registry keys. We have many objects that fall under artifacts, but these are some of them. Registry keys, web activity, event logs can be all considered as artifacts, and much more. So KAPE collects, or is a tool that is aimed to extract these artifacts, either from a live system or from a mounted image. Now, how it works. So KAPE first collects data, collects the artifacts, and then it processes or parses these artifacts. So how does that work? Okay, so KAPE collects artifacts or collects data through something called the targets. So it has a feature called the targets, through which we can define the source of the data. If it was a live system, mounted image, or even a specific path on the target system. So we define the target data source to be collected, and then we select what do we want to gather, what do we want to collect. This is configurable through the program. So basically we configure that in the GUI interface. Now when it comes to processing the artifacts, after we collect the artifacts, KAPE works on processing and parsing these artifacts. This works through the modules. So the modules can be set as tools, as you can see, to process these artifacts. Tools are configurable, and we can also add more tools to the program directory. Now we're going to go over the program itself, explain the GUI interface, and also explain how we can add modules and targets. Alright, so we're going to go ahead and open the KAPE directory on the desktop. Alright, so as you can see, when you first install KAPE, you will see these contents under its main directory. So we have KAPE. KAPE is the command line or the CLI version of KAPE. GKAPE is the GUI interface. We're going to go ahead and double click on GKAPE, and when it opens, we're going to go over the other contents. So get KAPE update, it's a PowerShell script used to update KAPE. So if you want to update KAPE, you're going to go ahead and double click or run this tool. Changelog, settings, and settings. So we have modules and targets that we have talked about earlier. So targets, as we said earlier, are the artifacts that are collected from a live system or a system image and copied to a provided destination. So basically, when we tell KAPE to, say for example, collect data from the C or the full computer, all the data in the computer, we need to tell KAPE where to store the collected data as well. So all of that is configured under the targets. So when you open the targets, we see the current directory contents. So these are the last 4 files that are considered as guides to create targets and compound targets. So basically, compound targets are a way to define multiple targets at once. Okay. And we have other directories as well. For example, we have the Windows. If you open Windows here, we can see different TKAPE. As you can see, the extension TKAPE. TKAPE is the extension that denotes that a file is considered as a target file. Okay, all of these are target files. So we can actually create our own target files to collect the target data. For example, RDB logs is a TKAPE file that contains data or instructions on how to collect RDB logs. If you go ahead and double click, open with, let's say with Notepad, so we see the description of the file, the author, the version, and here we see all of the instructions about the targets. So as you can see, we collect, this is the path of the directory or the data to be collected. Here's another path. So as you can see, this way you create your own paths. Okay, name it, give it a category, and path, file mask, and comment. So basically, all of these can be reconfigured, or you can add your own targets. So that's the cool thing about this tool. So these are the targets. By default, it comes KAPE comes pre-installed and pre-configured with all of these targets to collect. So when you run KAPE, it will collect these data from the source you define in the source section. Again, let's go to compound. So compound targets, these are targets that are, consist of multiple other targets. As we mentioned earlier, KAPE is often used for a quick triage collection analysis. The purpose of KAPE will not be fully filled if we have to collect each artifact individually, right? So we have, or therefore, compound targets help us collect multiple targets by giving a single command. For example, if we double click this one, our basic collection, open this one, so here we see the compound targets. All we have to do is to define or give the name of the individual target. These are the names of the individual targets. These are configured, as you can see, under say Windows, for example. So we define the path of these individual targets, okay, with the extension .tkape, and if we have a customized path, we can give the path here. So that's how compound targets work. Okay, now we have here the directory !! disabled. This directory contains the targets that you want to keep in the KAPE instance, but you don't want them to appear in the active targets list. So the targets list, okay, you can find it from here. So this is the GUI interface. If we enable the use target options, this is the target list. So if you want something to stay out of this list, you can put it under the disabled. Local. So if you have created some targets on your own and you don't want them to sync with the KAPE GitHub repository, you can just place them here. Okay. Okay, let's talk about the targets in the GUI interface. So if you want to enable the targets, you're going to go ahead and use target options. For the current scenario of this video, our target source will be the C directory. Okay, so we aim to collect the data from the C directory. The entire structure and the entire contents of the C directory will be the targets of the data collection in GK. Target destination, here is the destination of the or the path of the file or the directory, so identify the directory that will contain the contents of the collected data. So here we define the path as anything you want. So we're going to go ahead on the desktop and create directory called target collected files, and we're going to tell KAPE to store the collected data under this. So desktop. Okay, now from the list here we select what do we want to target as for the data collection. All of the target list here, as you can see, you can find them under the targets here. Okay, and they are categorized. So if you want to add targets to the windows, you can go ahead and follow the instructions to create a new TCAP file. The new target will appear in this list. Okay, now for the challenge of this video, we required, let me show you the challenge. So in the challenge, Organization X has an acceptable use policy for their portable devices, including laptops. This policy forbids users from connecting removable or networked drives. So no one is allowed to plug in a USB drive, and installing software from unknown locations, and connecting to unknown networks. It looks like one of the users has violated this policy. Can you help Organization X find out if the user violated the acceptable use policy on their device? The user's machine is attached. So what do we have to do? We have to collect artifacts, okay, that would display the connections to unknown networks and also the software that have been installed from unknown locations, and the artifacts should also show the network drives or removable drives that have been connected to the workstation. If we are able to collect these artifacts, we can prove a case that the person from the Organization X has violated the acceptable use policy. That's the objective. So based on that, we're going to get back, and from here we select the related artifacts to be collected. So if we search for USB, we can add the artifacts related to the USB device log. So you're going to select both these, and we're going to search for triage. Okay, we're going to select KAPE triage. So KAPE triage, as you can see, collections collect all of the data that have to do with the registry hives, system files, event logs, web activity, and so on and so forth. So most likely we're going to be able to find the requested artifacts using the KAPE triage. So you can also select this as well. Okay, now other things to configure here are the flush, add, %d and %m. Flush will flush the contents of the target collected files or the target destination. So if you select this option, any previously data that have been stored under the destination directory will be removed. Add %d will add the timestamp, and add %m will add the machine information. Okay, so that's for the target options. Let's now go ahead and explain about the module options. So the module options, as I said earlier, the modules are tools that are run to process the data. So the first stage, we collect the data, and the next stage is processing the data. So use module options, and here we select the specific tools to run. So the module source here, we define what are the data which we want to process. Where is the directory? Where is the source location? So it's better to leave this empty, as it will auto take it from the target destination path. So here we store the data, and we give the directory or the target destination path as an input to the module source. Module destination refers to the directory or path where we want to store the output. So normally the output is in CSV or text files, the output of the forensic investigation. So here we're gonna go ahead and select or create a new directory for the output. Output. Okay. Select the output and be done with this. And from the list, we can select the tools to run on the data. So we go back now and we select KAPE directory, modules. So we see something similar to the contents of the targets, right? So we have disabled, local. The same methodology works here. So we're not gonna explain everything from one more time. Let's go to the Windows directory. We see here files with mkape extension. Mkape denotes modules. So whenever we see mkape files, it means that these files are understood as modules by KAPE. You can also go ahead and open one of these files. This is how we define modules. We give it description, category. You can also create your own mkape files or mkape modules. And here we define the path to the executable that we want to use. Okay. This executable is considered as a tool that will parse and process the collected data. You can also customize the executable path to point to any tool that you have downloaded or you want to use instead of the current tool. It's better also to leave these files as they are and create your own mkape to install new modules using tools you have just brought into the scene. So this is for the modules. If we go to bin, as you can see under the bin directory, we have executables that we can run on the system. Okay, these are tools that are not natively present on the current system that we are investigating. Okay, so basically what you have to do, if you have tools you want to bring into KAPE, you can put them under bin directory. So KAPE will run executables either from the bin directory or from the complete path that you define in the mkape files. Okay, so an example of files to be kept in the bin directory are, for example, Eric Zimmerman's tools that we will use in this video. Okay, so now we have explained the modules and the targets. It's time now to run our own investigation and collect the artifacts. So once we are satisfied with the options, I'm gonna here cancel these. Okay, once we are satisfied with the options, we see at the very end or at the bottom the command that will be executed. So if you, in case you want to run KAPE or the CLI version of KAPE, you can go and copy this command and use the CLI version, which is here. For the sake of this video, we're gonna go ahead and use this option. So here, the GUI interface, and the last thing to do is to execute. But as you can see, we don't have the execute option activated for some reason. Target source, targets, double click to edit targets. So here selected the targets. Now the thing is, we didn't select the tools to run, so we're going to select Eric Zimmerman's tools. So Eric. Okay, now as you can see, the execute button has been activated. I'm going to click on execute now. I'm going to wait for a while for the tool to collect and process the data, then we're going to go ahead and examine the output. So when KAPE has finished running, we can check out the output folder. The output folder contains the investigation results, and we can see they are categorized according to the, as you can see, objective and the artifact itself. For example, we can see here the registry output. If you double click on that, we see all of the files or the CSV files related to artifacts extracted from the registry. Also, you see event logs, file deletion, anything has to do with file access, file system, and so on and so forth. Also system activity. Now, if you get back to the questions, see what are the artifacts requested. So 2 USB mass storage devices were attached to this virtual machine. One had a serial number. What is the serial number of the other USB device? So we go back. Now we need to open the artifacts. So we check out the EZ tools and we open EZ tools. Let's see where this tool is. EZ viewer. Double click on EZ viewer. And this will enable us to view the artifacts created in the CSV format. Now, while this is opening, most of the answers for the current challenge, you can extract them by looking at the registry, file folder access, and the system activity. So by looking through these artifacts, we can learn what are the connected USB devices, the softwares installed, and other related stuff that have to do with the mounted drives and other important artifacts. So this is opened. Now we go to open, file open, and then we go to output. So since here we're looking to, let's see here, information about the USB device connected to the virtual machine. So we're going to get back here and go to registry. Okay, let's see here. So if you click on device classes, this will bring up the related CSV sheet, and here we see the key, right, the registry key, and on the right we see the type of the device, the name of the device, and more importantly the serial number. So given in the question that the USB with this serial number were detected as it has connected to the workstation, we need to find out the serial number of the other USB device. So now we go back here. So this is the old one, and now we look at the type here, the type of the device connected to the workstation. So here we have SUSB and we have also USB. So looking at the name, we have two USBs connected to the workstation, Kingston and USB 3.0 and prod external device. So the serial number of this one, if you try it out on the questions, it will work as the intended one. And actually it is very obvious that it is an external USB that has been blocked. Other stuff might be, as you can see, prod external device, could be mouse, could be keyboard. So this one, Kingston, is definitely a brand of a USB external device. So we mark the answer and we plug it back. So here, next question. 7-zip, Google Chrome, and Mozilla Firefox were installed from a network drive. Location on the virtual machine. What was the drive letter and the path of the directory from where these software were installed? So since installing software from unknown locations is considered as a policy violation, we have to locate the location from which these software were installed. In the case of the current scenario, these software were installed from a network drive location. It means that a connected device on the network could be a NAS device, network area storage, was mounted on the network, and from that location these software were installed. We have to find out the letter of that drive and the path of the directory. Okay, so we go back, file open, and here we're gonna open the file folder access. This will give us the opportunity to locate all of the files that have been accessed either from within the computer or from a network drive or any external device. This will give us the chance to view the path from which the programs were copied and installed. So we're gonna mark automatic destinations and select it. This will bring up the sheet. We're interested in finding the path, right? So let's see here. On the left, This is the command path. Okay, let's see what other columns we have to expand. Local path as well. And scroll to the left. And we have this, the path. So the path marks the original path from which a file folder was copied or installed. So we have eKape and we have Z setups. And if you look at the destination, let's mark these two columns. Okay, so we have here eKape and Z setups. Now eKape is actually self-explanatory. It is the drive or the network location from which KAPE was copied. But Z setups marks another location on the computer or the network from which setup files were copied. So this marks the answer for the current question. What's the execution date and time of Chrome setup? So now we have to look at the executed files or executed applications. So we head to files, file, open a new file, go to output. We can find these under the registry. Now in the registry we're going to select recent apps from the list, and this will give us the applications. Not exactly this actually. Let me expand the application ID. Okay, so here we see the executed applications from the recent apps under the registry. And we can find here that Chrome setup, as you can see, was executed from Z setups network location. And here we can see the last access time. So this marks the answer for this question. What search query was run on the system? So now here we look at the search queries run on the system. So we can go back and open the related artifact, file, open, output, registry as well. Scroll down to the word wheel query, and here we can see the word wheel query that has been, as you can see, executed. In this case it was a search term. Okay, and the last two questions, one of which, when was the network named network 3 first connected to? So we want to look at the network connections or network Wi-Fi networks to which the client or the computer has connected to. So hit to system activity, and we double click on the network connections. Timestamp, not exactly this one. Let's go back. Output, system activity, try out network usage. Okay, so expand the SID type, timestamp, and I think this is not the location as well. We check out the registry again. Let's see if we can find something that is related to network connections. So application path, classes, known networks. So from here we see the first network, network 2, and lastly we see network 3. And on network 3 we see the last connected time, the first connected time. So the question is asking about the first. When was the network named network 3 first connected to? So it is this one, first connected local. And the last question, KAPE was copied from a removable drive. Can you find out what was the drive letter of the drive where KAPE was copied from? Again, here we need to look at the file folder access. So we go to open, output, and then file folder access, and we mark automatic destinations, open it. And we previously answered this question, but we're gonna again mark the answer. So if you go to path, scroll down, you see eKape. This is an external drive letter from which KAPE was copied. So this marks the end of this room. I hope you guys learned how to use KAPE, and I hope the answers to the questions were useful. Thank you for watching.